Hello folks, welcome and welcome back. Something horrible has happened. I thought I was recording, but I did a lot of things, explain everything, and at the end I've realized that I didn't press the button to start the recording on OBS Studio, a small button that it's sort of redundant with the okay. So then after I don't know how many 2 hours of streaming, non-streaming, okay, so I can't redo what I did. Unfortunately, it was not even recorded, I think, in YouTube. So if I find a way to get it back, I will post it like a non-live, okay, because there was a lot of content there. But let me show you what I was able to build. Really sorry folks, never occurred that. Maybe I was too anxious to start, and I never understood why YouTube has the same button as OBS Studio, and you have to, yeah, so it was really bad, my bad. Okay, so let me show what I did in that session. Where is the the armature? Okay, then we have the space switching, no, not space switching, the screencast, bone manager here, bone manager. So I'm extremely tired now because I was working all the time, showing, presenting, talking, and okay, not this, but I will show what I've done and try to explain it once again. So okay, so what I made was I built for the what I was calling a fake, yeah, I see that hips thigh joint fake displacement, and I checked this positively. So what that means is that I had this is the fan bone, which has the rotation feature here, the copy rotation inverse, so it derotates the mesh of the thigh. But it's what I've built was these things. I've made that besides the rotation, the derotation, right? So the bone here, the fan bone, it's called a fan bone. It has the same starting position, like the same joint, shared same joint of the thigh bone, but it is parented to the thigh bone, and it has a copy rotation bone constraint that has a limited influence in invert local space on orientation, local space. So what does that do is that it will rotate, because the parenting and the copy, yeah, it will rotate exactly the same. And then as the thigh rotates in whatever direction, side, doesn't matter, it will rotate on a lesser amount. So let's copy that. So if it was maximum influence, it will derotate a lot. But if it is zero influence, it's like if it was disabled, it will rotate exactly the same. But we don't want that, we want a derotation, so that's why we give a slight influence, so it will be something like a 15 to 30 degrees derotation, right? And then of course there's the wave painting, because both the thigh bone is a deformed bone and the fan bone, but the fan bone focus on the joint, avoiding the belly, avoiding the buttocks, although there's some here, but so because it's really focused on this volume loss, the horrid artifacts that may occur somewhere around the type. This can be played off, but usually we don't want the waves of this to be blended shearing to the extent of the thigh bone. It's really just about this region, the joint region, more precisely of the thigh, not so much on the torso, but then we can vary. And on top of that, because there is knowledge that the artifacts that are generated through rotation, they sometimes what we want is the mesh to push it back as the leg goes up. We want this mesh to be pushed back. But if I do this on the deformed bone of the thigh, which is a structural bone for the limb, right? I'll be moving the joint, and that's ridiculous because maybe it works, but it's unnatural. We're moving the pivot point of the thigh. It's not like that in real life, right? There is the bone rotates over a pivot point, right? So, sort of, and then it doesn't do this displacement, right? Maybe it does a little, I don't know. I don't think it does really. And so this is very bizarre, even though it can solve the problem of the mesh, but it's very brutal, right? And then for the opposite direction, when there's a back bending, here the deforms are bad because I turned off some helper bones that I have here, not care about that right now. And here's the opposite. You want to spread this and move this, move it down. So actually in here it will be good that I enable this to display. I'll show you the bone constraints that I've developed for the, so I need to alt click select this. Let's just turn this, it needs to be on pose mode to access the, or edit mode. Okay, so this profile bendy bone splines, which I've already explained on the last session, I think. The first video that is out there is published already on live streams. Okay, so you see there is, I've displaced that, right? So we want this part is critical, right? So we want to push this apart, this mesh apart, and then push this down just a bit. Depend on the model, depend on many factors, but depends on wave painting, of course. But you see it's the opposite. Here we want to push this apart and apart, and while here in the front bending we want push this here and then here. The problem is that of course this is a structural bone, but then we can use this bone, reuse the same deformed bone, the fan bone, which is a helper bone, to, besides the rotation that I have here, can also have additional, the same things that I showed there. And so what that means is that I've already set up, so it's tedious, but let's the logic is simple. Yeah, we won't be able to address every detail here, but this is these two are for the front bending of the thigh, and the map from is the same, is x0, so it's the x rotation of the thigh. So this is from the rest position of the armature. So this is 0 degrees. So from this 0 degrees to maximum, this is front bending, so this is like that. So from this rest position 0 to an angle of somewhat positive 135, so I think it would be, so this will be 90 and this will be 180. It doesn't go so far, so something like 90 be here, so it would be something like here, right? Half 90 plus 45, so halfway to it will be, so it's more or less like that, the maximum that the positive x-axis rotation should go for this leg, I assume for now. And so this is the map from for the front bending, so it's equal on both, on the, it's equal for both of these, right? Except that this is moving the y-axis, is related to that, so that is not more map from, it's map to. So you have just all on x, just to simplify, add, because we don't want to, we want still to be able to move that, at least for experimenting. For building up the rig, we need to test the mesh, the forms. So we give it a negative, so this means that it go negative y. So that means, yeah, on local space, target the depth on its quaternion, yeah, whatever. This is exactly as the bone it is here on its transforms, right? Quaternion that I'm using for all the bones of this rig, I think. So, okay, no map from. So the idea is that 0, so this bone constraint won't do nothing below, from 0 to below, and above it would already do, above 135 positive degrees, it would leave the maximum as it did. It is strange, but yeah, left, it will stop affecting gradually even more, so that will be a limit, but it will anyways. And then the back bending is same thing, except that I've used the map from would be negative 135, which I've calculated is like something here, which is even more that she actually is doing on the animation, right? So it would, but that's approximate, so that's good, and maybe I want that in the future. So I've analyzed that we could put them, mix them together, but that is not good for some clarity on the orientations, folks. So so okay, in the case of the front bending, I've already showed what the, so if I wanted to use the others, yeah, I could use. The problem is that my rig, my rest position here is not regular. You see, it's not a T-pose on edit mode for the mesh, nor for the armature, and so this means that the orientations of these bones here is not aligned with world space, for example. So they are sort of, this irregularity is not good for this data. For the y, it doesn't matter, right? Y-axis of the bone, because the length of the bone represents the length of the bone. However, for the x and z axis of the bone, right, this motion, this starts to have problem for organizing orientation, because if I, so what I did to solve this is that, okay, target local space this, but since the axis of this bone is bad on rest position, what I did is that I use owner. Instead of using its own axis, I've used the custom space, target the armature, target another bone of the armature, which happens to be aligned with world space. It's a control bone, right, of the lower torso of the hips, right? And that bone, we don't see it here, but it should be, yeah, it doesn't matter. Oh, okay, it's this bone anyways. It's, we can pose it, and yeah, we can rotate it, but usually I think that will out the z-axis will all be the one from rest position. And even if it rotated on pose mode a lot, that and that affected the orientation, I don't think so. I don't think it is dynamic like that. So it is always the custom space of that bone, command hips, how I call in that hierarchy, from the rest position reference. So it's a static axis, just as this one. If we used, yeah, I think it's static. So this means that when I decide, not for map from, but which relates to the target, but target bone, but when I go to map to solve the x and z axis, these values are based on these axes. And so I can really, even though the axes of these are crazy, not crazy, they are just not orthogonal in relation to workspace, they're not aligned with workspace, these will somewhat do the job. So you see that these will go up and down as in workspace, but actually not workspace, but that position of the bone, that bone, yeah, it's not workspace, it's still another bone. So and then x-axis, same thing. So you see, this gives regularity to the rig even if I didn't have from the start here. So custom space I used here for only for the owner bone. Otherwise I'll have to recreate that from the same bone constraint, so I wouldn't be able to use this. I will lose the y-axis for this because it will be using the axis of the other, unless I had another mapper bone just for the axis that would have, yeah, no, it wouldn't work apparently. So so I can analyze, separate the things. Otherwise, yeah, I'll have to get here and try to build the position that I want through by both, and this is kind of inefficient, right? Although it's sometimes wiser to have lesser bone constraints, by just creating another one that is very similar, by analyzing, this gives more control over the rigging, so this is good. And so this I decide to keep. So one, I control the height according to that. Of course, the target, it's still the type, so it's same thing for all of these bone constraints. But for this is up and down, so it's not really the x-axis. Oh, actually, it will be, yeah, z. Let's say xz. Well, I'm not even saving this file, I already saved. So this is like just a review because I didn't record. So here, this was a terrible mistake, but whatever. And then the back bending is the same thing, except for the opposite side. And yeah, it's inverse. So this idea, it just goes. So this map 2, so this goes positive instead of going inwards, go outwards. The logic is all the same, it's just that it is the contrary or the inverse in some aspects. Not gonna describe every inversion, but I think you get the idea then. And for this is the same target, it's the same bone I'm using mostly for its z-axis, but that represents the moving down, so I can move this down negative, I think, map 2 z, yeah, so it goes negative on the minimum as the minimum evolves negatively. So in this rig particularly, the x-axis rotation of the type is negative on this direction and positive on that direction. It might not be the case, but this case was like that. So it's easier to write. And so folks, that was the shorter version. I'm really sorry for that, but that was the hip stiff joint fake displacement, so that I can displace the mesh on analytic ways that are usually what the other independent helper bones, deformed bones, would do to the mesh. It's the sort of motion mechanism that we want for this mesh of the critical mesh of the joint that suffer from horrid artifacts on many directions. Yeah, there's side bending, but I didn't solve that for that bone. I don't even think that there might be something to do on the side bending for this bone, because it's different. Whatever I moved there, it doesn't seem to help. So I think this is something that go more specifically for the front and side bending. Yeah, there's inner bending, but then it's still the same thing. It doesn't seem to help for the side bendings, only for front and back bending. So far, that's what it seems to me. So this is would be it for that. So it's a stacking of functionalities for this bone, and I can use a single deformed bone to derotate the mesh and displace the mesh of the joint. So this is, I believe this is clever, because if I separated that on several different deformed bones, I will be doing just as I did here. It's not bad, but it can cause problems, because it is the we are using a lot of blended waves, and it's very easy to have problems with that. So I turned this on to show that this rig setup, I want to simplify it, but that will be the fourth experiment. So this third experiment was successful, and I intend to keep this upgrade. Usually fan bones, they don't do that. Now my fan bone is doing that, the displacement. So it's a fake displacement of the type, but it's a real displacement of the mesh. So, and this, it's not interesting that this affects the belly or the buttocks. I want to affect this through, so this is more about this circular, the pubis, all this mesh, this joint or connection between the flesh of the buttocks and the muscle of the that starts, some muscles starts from here, I guess, behind the thigh, the upper thigh. And so yes, so maybe those motions sometimes may be subtle, otherwise we'll get bad results out of it. But this depends on character design, right? And if it does too much of something, we can neutralize it from maybe changing waves, maybe if we have more helper bones, which is my intention, of course. So I want to substitute this with another experiment, but that new experiment, the fourth one, will be built on top of what we have here. So I'm keeping these four here, would be the upgrade, the fake displacement, and for me it makes sense to solve analytically the artifact, but after even if we solve the artifacts analytically, the shapes might still not be good enough, and probably cannot solve totally the artifact even with those. Even the best analytic solutions won't solve, well, if maybe they would solve the artifact, but then there's another rigging challenge for organic rigging at least, which is solving the shapes, right? The anatomical shapes. So one thing is really countering artifacts or neutralizing the artifacts. And another problematic is really good anatomical shapes. This is a more artistical thing. So countering artifacts or neutralizing artifacts is a more technical aspect of the job, and it's very confusing when you have to solve both technical and artistic problems simultaneously. So this is why I'm doing my best to get as much neutralization of the artifact as possible, even though it's very difficult. And a good way to check this is to turn off the most bone constraints and see. So here, for example, this is not necessarily yeah, we see there should probably be an artifact here, and maybe this is too exaggerated. But this is not necessarily artifact. I mean, this could be also because we don't have, after I turn this off, I don't have a buttocks leverage system yet here. This served as a buttocks leverage and also as a belly leverage. I'm not gonna show you the detail here. There were stacking functionalities, but that was good for this system. But I want to simplify this thing, but I'll build that experiment on top of that. So the next experiment that I'll be doing in another session, that was my decision anyways, from the live stream that I did that wasn't shown today, is the mapping things. I'll create some mapping structures that will be floating mechanism bones that will serve as target reference, so I could better automate some bone constraints of bones such as this. I don't know if I would use this system exactly. I'll try to use something simpler, but anyways, these ones I want to simplify them. There are many reasons for that I want to do that, attempt that, because this system is already working. You see, the deforms were actually not too bad, but we could improve with some retakes. But I want to simplify even more this thing. So you see, here we have some sort of buttocks leverage system. There are some bad deforms there. We could take off some waves, do something about that. Here I also have control on the crotch region. This is important. So yeah, but it's kind of hard work having to use this bone constraint, and then they start to conflict at some point. Not terrible conflicting, but yeah, it can become messy at some point. The diagonals, I spent a lot of time talking about that on the video that wasn't successfully displayed, because they usually are orthogonal settings, back, side, yeah, usually Y, yeah, back and forward, and left and right. So, and when we go diagonal, we are sort of in a lost space between, because then the resulting shape, maybe we fix good shapes on the back bending and the side bending, but then you look here, oh, it's in an in-between pose, is not good. Then, oh, let's just move here from that pose. But then we just destroyed the progress we did on both. But we got good here, but then we got bad there and there. And this is happening because the bone constraints, they were developed orthogonally, and this is very hard to solve We need a lot of back and forth. And sometimes it's like, yeah. So I believe there might be a solution for that. But yeah, there are, for example, this could help. No, RBF nodes editor, it's an add-on that use drivers, it automates. So it's if I give on that pose, you will be exactly here. It will calculate everything, and then on that pose there are some caveats that sometimes defining a pose is not so simple. We might need an extra bone just for that. It might be confusing. And then, but the major negative aspect for me at least is that since it uses drivers, it does a lot of calculations, it will lag the posing, or and for me this is a no situation. But if it can use, if one can use without caring about the lag, or the lag can be avoided, I couldn't. So then this could be a solution for that. And drivers for shape keys, corrective shape keys, have the same problem as I was describing here, because you make for this orientation, then you make for this orientation direction, right? And then, well, what about the in-between? Then you start to solve the in-between, and we mess up with the others. So yeah, so that's it, folks. Sorry about again the video that wasn't shown. I will continue next time, and then I won't make that, never again, that mistake of not clicking the OBS Studio Go Live button, and then never happened before. So happy blending, folks. I hope even I wasn't building here, at least I tried to explain what I was doing today. And so see you next time. I hope tomorrow I'll be doing the continuation. It will be session 3, and then we'll go for the last experiment. Maybe could require a bit more iterations, because but in the end we will have a good pelvis rig for this character. It's already, as you see, mostly good and very radical posing, but I want to make an elegant solution, and for that it requires a bit more research, right? And that is what we are gonna do on the next session, I hope tomorrow. And let me see if there's anything else. Yeah, okay. And then if I succeed with if the last experiment is successful, even if it takes 1, 2, or 3 iterations, because if it fails, I'll go back to this stuff here. I'll just retake until it's good enough, which is hard work, but it's feasible, perfectly feasible. So if I success with all that, I will try to make a guide about how a rig right there, like with all the oddities of this this one, can be done. Not that this will be ideal. I'll mention all the problems, and I'll show how the problems can be, each of the problems that I found, that I encountered, can be mitigated, can be dealt with appropriately. And so and then perhaps I could also make the version with a regular rest position and without another oddity that I have here, which is that I'm using preserve volume option, which is dual quaternion skinning, which is bad, we cannot export it for, cannot bake this thing. It's not bone, it's not armature, it is mesh related, it's the skinning algorithm. And if a game engine, for example, or another CG software does not have dual quaternion skinning, this is useless. It's like an object modifier. It cannot be reinterpreted. So the mesh will deform differently, even if the bones are the same, even if the wave paint is the same. So it will be from this to this, or the from this condition to this condition. So we cannot have, so this is not a good idea, besides the fact of the warp artifact. If you don't know, if the mesh is rotated from this rest position to 180 degrees, yeah, did I show that? I don't even remember. It will be like this, you'll see on the foot there. We don't, so let's say start here. As it reaches 180 degrees or negative, this is crazy. This is the warp, what I'm calling the warping artifact. There's no solution to that. This is algorithm basic. This is a major drawback, horrible drawback. This is why this position is the best I found so far to avoid the warping artifact on any limb as it rotates. Maybe on very exaggerated pose it will still happen. Yeah, it will happen. But if with this sort of X pose, an X pose, right, instead of A pose or T pose, this will mitigate, this will delay. This is actually feasible. I've tested thoroughly, not enough perhaps for 3D animation, but I didn't found any pose that I wanted that suffered the warp artifact, because 80 degrees rotation is a lot already, right? It will be like, oh, this leg should be here if it was bent backward or front. So it's like, it's not something. The arm is more delicate though, because if we have the arm totally crossing the torso here, that won't happen, but we could do something like that in real life. And there is contortionism, right? So there are circumstances that it will ultimately fail. So this is very unfortunate, because it saves time in making extra bones that will solve volume loss, because that's why it's called preserve volume. It literally preserve volume on the joints. The volume loss is volume loss artifact. And but there is even worse than that. Yeah, there's the small volume loss and there's the big volume loss, which is the worst thing that usually happens here, and from the front bending will happen here. It's volume loss, yes, but for me it's even bigger. It's not the candy wrapper artifact. That will be twisting the limb, another thing. So yeah, so I need to make a guide for all these techniques if they end up ultimately successful on my experiments. This character, yes, I would like to have a version, regular version, right, without that, and T-pose, which for me I think is the most regular, even though because of the alignment, yeah, it is desirable, but there are also disadvantages. So here, okay folks, so that's it. Thanks for watching. Sorry again for the issue that I'll do my best to avoid it. At least is that would be the first time and only time that that occurred, that I forget to press the record button. No, not the record, the go live on OBS Studio. Hope you like the content, and if you have any question, then you can put in the chat. Not in the chat, yes, the chat, but I meant the comments, because the live stream is ending now. And tomorrow we'll be continuing. I hope tomorrow I'll make the session 3, and then if everything goes right, this pelvis rig will be finished, and then certainly a good tutorial on that or something like should be made, because it works. So that's it, folks. Take care and happy blending. See you next time.